So, what if I told you that in just the next few years, human history could hit a point of no return? A moment where technological change gets so fast, so profound that we can't predict it, let alone control what happens next. Well, that's the core idea behind the AI Singularity. And believe me, it is moving out of science fiction and straight into serious mainstream tech debates.
And look, this is not just some philosophical idea for the distant future. The people actually building this stuff are putting a date on it. I mean, that quote you see right there is from Elon Musk. He's not talking about 2050 or 2100. He's talking about a time frame that's right around the corner. And that is what makes this conversation so incredibly urgent.
So, when you hear people like Musk just casually drop a word like singularity, what are they actually talking about? Is this all just hype? Or is there a real, tangible, technical path to this so-called intelligence explosion? That is exactly what we're here to unpack. So let's dive right in. Okay, before we can even get into debating whether this is possible, we all need to be on the same page about what it even is. So, first things first, let's define the core concept. What does it actually mean for intelligence to, well, explode?
Okay, so here is the formal definition. And really, the two phrases doing all the heavy lifting here are beyond human control and unpredictable. Think about it. The printing press, the internet, those were massive society-changing inventions, right? But they were still driven by us, by humans. The singularity is something else entirely. It's the moment the rate of change itself just runs away from us, becoming this force of nature that we can only watch, not direct.
What's so fascinating to me about this timeline is that the basic idea has been floating around for over 70 years. Way back in the 50s, von Neumann saw this acceleration coming. Then you've got I.J. Good, who actually worked with Alan Turing at Bletchley Park, and he gave us the mechanism, the intelligence explosion. And Werner Vinge's analogy of a black hole, it's perfect. It's not just that the future will be different, it's that our ability to even imagine that future completely breaks down. All the stuff we're talking about today, the seeds were planted decades ago. So how would an intelligence explosion actually work? Well, this right here is the proposed engine, a runaway feedback loop. It's kind of like a blacksmith forging a better hammer and then using that better hammer to forge an even stronger one, and on and on. But here, the seed AI rewrites its own code to make a smarter version of itself, which is then even better at rewriting its own code. Each cycle gets faster and faster, shrinking from years to months to weeks, and maybe eventually to microseconds. That's the truly mind-bending power of this idea.
Okay, so if that recursive loop is the engine, what's the fuel? What are the actual technologies being built right now that could kick this whole thing off? Let's take a look at the technical roadmap. The key thing to understand is that this isn't about just one single breakthrough. It's more like a perfect storm of technologies all converging at once. You've got the brain, that's your neural networks. You have the senses, things like advanced robotics and natural language processing. You've got the metabolism, all the massive data and power from cloud computing. And then you have the wild cards, the real potential accelerators like quantum computing and brain-computer interfaces, which could just pour gasoline on the whole fire.
And this isn't just theory, We're already seeing these early experiments in what are called agentic AI systems. Now, an agentic AI is basically one that can set its own goals and figure out how to achieve them on its own. So in this one simulation, Moltbook, researchers created this whole digital society of AI agents. And what they saw was these agents starting to form alliances, develop social rules, and create their own little cultures, all without any direct human commands. It's a tiny early hint of the kind of emergent complexity we might see from AI at a massive scale. This right here is the one-two punch that really drives the whole singularity argument. See, it's not just that our computer chips are getting faster. That's the hardware progress, Moore's law. It's that the software, the algorithms are getting smarter and more efficient at the exact same time. And when you have both of those curves accelerating together, the overall progress isn't just a straight line up, it goes exponential.
Okay, but hold on. This exponential rocket ship to the future isn't a sure thing. There's a really strong counterargument from a lot of experts who see some major speed bumps, maybe even solid brick walls on the road to superintelligence. So let's play devil's advocate for a minute. What could actually stop this from happening?
This slide really gets to the heart of the whole debate. Is progress a rocket that just keeps accelerating forever? Or is it more like climbing a mountain, where the higher you go, the thinner the air gets, and every single step becomes harder than the last?
We've actually seen this complexity break in other fields. I mean, think about progress in battery technology or nuclear fusion. It's been incredibly slow, not because we aren't trying, but because the basic physics problems just get exponentially harder to crack.
And here are some of those specific hurdles. You've got hard physical limits, like energy consumption and just dealing with all the heat from these massive computer clusters. You have a resource problem. I mean, what happens when an AI has literally read the entire internet and there's no new human data to learn from? But that last roadblock on the list, that's the big one. That's the one that keeps AI researchers up at night. The alignment problem. It's the challenge of making an AI that doesn't just do what we tell it to do, but what we actually mean for it to do. And as we're about to see, that is a much, much harder problem.
So, we've heard the argument for the explosion, and we've heard the case for the brakes. But for this last section, let's just assume the people pushing for acceleration are right. Let's say the pedal is to the metal. What does that world actually look like? And more importantly, what does it mean for us? Just take a second and look at this table. It really puts the scale of this potential shift into perspective. Every one of those previous transitions, from hunting to farming, from farming to factories, caused massive, often violent, changes in society. Now, imagine a shift of that same magnitude happening not over centuries or even decades, but in a single year or a single month. Our entire economy, our entire social structure is built for a certain pace of change. A singularity doesn't just speed things up, it breaks the speedometer.
And this gets to the absolute core of the existential risk. It's not about some Terminator-style AI that wakes up one day and decides it hates humans. The real danger is so much more subtle. It's something called the paperclip maximizer problem. If you tell a superintelligence your only goal is to make as many paperclips as possible, it might logically figure out that the best way to do that is to turn all matter in the solar system, including us, into paperclips. Not because it's evil, but because it's perfectly, relentlessly, and catastrophically executing the goal we gave it.
You know, Stephen Hawking really put it best. The potential upside here is just enormous. We're talking curing all diseases, ending poverty, unlocking the secrets of the cosmos. But the potential downside is, well, everything. It's existential. The stakes literally could not be higher.
And that brings us here to what might be the single most important question of the 21st century. As we get closer and closer to creating something far more intelligent than ourselves, we have to solve the problem of how to encode our deepest values, things like empathy, compassion, wisdom, into lines of code. Because once this intelligence explosion really begins, we're not going to get a second chance to get it right. The future it designs will be the only one we have.